so we are still in lesson 3.4, and our learning goal today is being able to use the graph instead of using the equation and plugging values into the equation to get the given. So we have a domain value, we plug it in, we get a range value. Instead of doing that today, we're going to use a graph to find a domain value or a range value. So they will give us one and ask us to find the other. But instead of plugging it into the equation and finding it algebraically, we're going to find it using the graph, such as they did in that example 3 I just had you study. So tell me, what was the function that the graph represents in example 3? Or in other words, how did they get the points to be able to draw the line to create this graph that we're going to use? Remember?
F of x is equal to 1/3 x plus 2.
F of x equals 1/3 x plus 2. So in other words, to get points, pick an x value, take it times 1/3, add 2 to it, there's your function rule. That will get you the what? Take the x value, multiply it times 1/3, add 2, that will get you the y value or the f of x value, right? Do they mean the same thing? Okay. So what were they doing in that one? What did they use the graph to do in example 3? No, Trevor does not get to bail you guys out again. What did they use the graph for to find in example 3? The graph of f of x equals 1/3 x plus 2. Did they give you a domain value? Did they give a domain value and ask to find a range value, or vice versa, give a range value and ask to find a domain value? Which one was it? Max?
They gave it a domain value to find the range.
Okay, and what domain value did they give?
6.
6. So they said when x is 6, says it was the domain, and apparently they said when x is 6, find f of x? Is that what it said? How did they do that? How did they find f of x when the domain value was 6? What did they do? Zach?
They timed it by 1/3 plus 2.
That isn't what they did. They checked their answer after they were done with that. How did they find the f of x value, also known as the what value again? The y value. How did they find the y value of a point that has an x value of 6? They did not use the equation to find that. They did use the equation to check it. Jennifer?
They moved up on the graph the function and moved left on the y-axis. to
Yeah,
find the
so
corresponding-
did they not do something like this? Did they go to x equals 6, 1, 2, 3, 4, 5, 6? And then they followed up to where x is equal to 6 and said, oh, look at right here is a point on the graph. And at this point, the x value is 6. What's the y value? 1, 2, 3, 4. It is 4. And then I believe they plugged 4 in, or that they put 6 in, and for x, and they put 4 in for f of x into the function and checked to see if it checked out. Did it check out? Okay, so that's what we're going to be doing. Now we're going to use that same graph, and we're going to do check it out problem number 3, which is below that example. So when they say use the graph to find it, we do not do anything algebra. But then when they tell us to check our answers, that's when the algebra comes into play. So get rid of that one, that was the example. For check it out problem number 3, it says use the graph to find f of x equals 3. Use the graph to find f of x equals 3. Well, remember, f of x is the same as what? Y. F of x is the same as y, so they just gave us a what? A y value, didn't they? They just gave us a range value. Now we have to find the domain value, the x value, that goes with it. So when they said to find f of x equals, use the graph to find f of x equals 3, they didn't give us a range value, excuse me. They said, find f of x. Remember, f of x is the same as y. So they're saying f of x is 3, and we're supposed to find out what the x value is. So yes, they did give us the range value, and we have to find the domain value using the graph. So what are we going to do? What are we going to do? Cameron? If y equals 3, what do we have to do to find our x value using the graph? No, there's going to be no multiplying involved when you're using your graph. Jennifer?
On the y-axis, go up 3.
Okay, so go up 3. So here's the origin, the middle. So we're going to go up 1, 2, 3. Are we on the graph? No, but what do we have to do? Move right. So in other words, move now along that y value till you get to the graph and stop right there and say, okay, now I'm on the graph where I have a y value of 3. And what's our x value? Is that 3 also? Just so happens that the x value at that ordered pair is also 3. So when y equals 3, guess what? So does x in this case. Okay? Now we will use algebra to check our answer. So now we'll put it into our function. What's going in place of f of x? 3. What's going in place of x? 3. Kind of hard to screw this one up, isn't it? They're both 3. So we can mess it up and still be right. So 3 is 3. A third of 3 is 1. So 1/3 of 3 became 1 plus our 2. And now we just bring that 3 down again and say, what is 1 plus 2? 3. So it checks out, doesn't it? Okay, now you try one. I did an additional practice, not one that they had in the book. I did another one. So additional practice. Use the graph to find the value of x when f of x equals 1. Use the graph. And then it says check your answer. They know because they checked it out and you're feeling really confident you have the correct x value. You got it, Max? What is it?
-3.
-3. He thinks when f of x is 1, x is -3. Do you agree? Anybody agree with that? And it checked out algebraically? Okay, how do we get that on the graph? So in other words, we're not going to use that equation to get it, but we're going to use it to check it. So we go to y equals 1, right? F of x is the same as y. So they just told us the y value, so we go up to 1. And which direction do we have to go this time? To the left. To land on the graph, we got to go this direction. And that is ordered pair. Well, it's going to have a 1, because that's where we're at. And then what's the x value? 1, 2, 3, -3. Yeah. Okay. So then we take our y equals 1, x equals -3, and put it into our function and see if it checks out. So 1 is 1. A positive times a negative is a negative, and 1/3 of 3 is 1, okay? And then bring down our +2. 1 is still 1. No reason to rename it. 1 plus 2 is, oh, it's -1. -1 plus 2 is a +1. It checks out, doesn't it? So I should be able to see how you're using your graph, but you're not using algebra to get it. You're using algebra only to check it, right? questions about that? No? Okay, then let's go to the next page in your book. You should have to flip the pages to move over to example 4. And do just a quick scan of that problem. Example 4. Scan that problem in your book on page 189. So this problem is a little bit more involved, isn't it? Did they give the graph? I don't think so. I think they gave us what? A function, and then if that function had to be graphed. How did they find points for the graph? What did they do?
You gave us the miles per hour.
They gave us miles per hour, which was in our function, right? So how many miles per hour is it, by the way?
6.
6. So what's the function for this one?
Y equals 6x.
Y equals 6x, okay. So they gave us the function for it, and then they found some ordered pairs by doing what? Magic? Did it just happen? I think it's one of the steps that told you to do what?
Negative values of x.
Choose some x values to, why non-negative? Why did they choose non-negative values of x?
Because you can't have a negative, like, you can't have a negative for number 4 checks out, you can't have a negative miles per hour.
You can't have negative number of years, right? Isn't that what's on the x-axis? Can't have a negative number of years, and what's on the y-axis? Yeah, rise in sea level measured in millimeters. Can you have a negative distance? No, so that's why they said, okay, first of all, let's pick non-negative domain values because you can't have negative time. And then if you don't have negative time, chances are you're not going to end up with negative distance either, right? Okay, so they made a table and they had to decide what kind of x values would be reasonable in the table. Don't pick ones that aren't reasonable, okay? Well then, what's the function for that one? Y equals 6x, really? Does that one have the same function? Or did I write the wrong one down from my other one? And nobody's caught me all day.
Y is equal to 2.5x for the example.
Yeah, this one for the example is y equals 2.5x, isn't it? Yeah, it's 2.5x. It's in the check it out problem that we're going to do that it's y equals 6x. Okay, let's go on to the check it out problem. Let's do what they are asking us to do in that one, okay? So this one has to do with, it says the fastest recorded Hawaiian lava flow moved at an average speed of 6 miles per hour. The function y equals 6x describes the distance y. So they're telling you the distance is represented by y. That the lava moved on an average in x hours. They're basically telling you the hours are representing, the x values are representing the number of hours. Graph the function. Well, if we're going to graph it, it would be a good idea to decide, first of all, what seems like a reasonable domain, just, in the first place, okay? So in this particular situation, we have hours being represented by the x value. We just read that. We have distance, the y values are representing the distance in miles. So the domain is hours. Should we say the domain is all real numbers? Can we choose any number we want from the domain and it makes sense to this problem? Hours. What's a reasonable domain for this problem? All real numbers? Negative 100? Negative 2 billion? Negative infinity? Is that reasonable? When we're talking about hours? No. Where would we start?
Positive.
Could we start at 0? Can there be such a thing as at time 0? Is that the start? Right? So I'm thinking that a reasonable domain for this one, let's identify it. A reasonable domain is x is what? Can hours be measured in parts of hours? Like minutes and seconds and parts of seconds and, So It's continuous, isn't it? So could we write it like this? X is greater than or equal to 0? Would that represent hours of time? 0 being the start, and anything past 0 would be positive. Okay, and then when we're done graphing it, we'll be able to identify what seems to be a reasonable range for this also, right? Okay, so if that's our reasonable domain, we have to pick some x values that are in that actual domain. So why not start at 0? And then let's be lazy and let's just pick whole numbers. Let's do at least 4 points so we have a good graph, okay? So we're picking x values 0, 1, 2, 3. We're trying to get our graph put together. So now we will put in our x values into our function rule and see what we get for our y values so that we can put together some ordered pairs. So go ahead and fill out your table, because you know how to do this. And then before we go and graph them, we're going to stop and talk about how graphs look, because I've seen some of the craziest graphs in my correcting. I've seen things like, well, if on the y-axis you need a 10 and then you need a 32 and then you need an 80, you can just graph it like that. Can you? And if on the x-axis you need a 5 and then you need a 10 and then you need a 20, you can just graph it like that. No, these are number lines, right? And distance between things has to be equal. We have to have good number lines. This is poor number line sense. So we need to go up to our graph, and it's already, by the way, when a graph is not labeled, not numbered, we assume it's going by ones, unless we change it. Okay, we assume it's going by ones. So let's look at the x-axis. Does the x-axis have a scale of 1? Is each and every grid line on the x-axis 1 unit or 1 hour? Really? Every hour is labeled up till 6 hours, but what about this grid line right here? That's a half an hour, isn't it? Because 0 is right here at the corner. So this is a 1.5 hours. So this has got a scale of 1/2. It's going by half hours, not whole hours. How about the y-axis? What's the y-axis going by? What's its scale? Every grid line is what? 5 what? Miles, okay? So in reality, every time we go up a grid line, we're going up 5 miles, aren't we? So they each have their own scale. They're not going by ones, either of them. So now when we graph our points, we have to take that into account. So go graph your 4 points and make good decisions where they should go. And then I'm going to pass out some rulers to you because this is a continuous graph. So we're going to draw, we're going to connect the points. And in your homework, you should use straight edges when your points are in a linear fashion also. Now, should it be a line though, or should it be something else? So my question was, should it be a line or something else? I'm thinking that it should start at 0 and then just keep going that way, shouldn't it? It's a ray, not a line. It doesn't have arrows at both ends. It's a ray, not a line. We don't want anything going past that corner there. We don't want any negative time. We don't want any negative distance. We want everything to be positive. So then, what's our range? What's a reasonable range we could say for this one? Is our range that 0, that 6, that 12, and then 18? Is it a continuous graph or a discrete graph? Continuous. Can we name every range value value or every domain value on a continuous graph? No way. So we're gonna have to do this as an inequality. What would our reasonable range be for this? Trevor?
0 is less than or equal to x.
I think it's y, isn't it? And I'm just gonna turn it around the other direction because most people it makes more sense this way. You can write it your way though. Y has to be greater than or equal to 0, right? Because at the end of that ray, the y value is 0. So right here at this point, we have 0, but everything beyond that on that line is a y value greater than 0. So there's our reasonable domain and range. Now let's finally get down to the meat of the thing. It says use the graph. Use the graph. Would you circle that, please? Use the graph, because I'll tell you what, I will see students all the time use algebra when it tells you to use the graph. Use the graph to estimate how many miles the lava flows or has moved after 5.5 hours. So how are we going to use our graph to do that? What are we, pardon? Okay, so where do we start? Where should we go? What should we do? We're going to put points to meet up. I don't right now, and I'm sure there are any that do. Is that?
On the x-axis, says go to 5.5.
Go to 5.5 on the x-axis, which would be right here, correct? Okay, and then do what? Go up until it hits the graph, and right there, you would say, oh, here's 5.5 hours. About how many miles do I think that is? So I look over to my y-axis and I say, that looks like it's about 30?
35.
I think it's a little weak. I think it's somewhere between 30 and 35, right, isn't it? Shouldn't it have turned out there? If you graphed your points right, it should turn out somewhere between 30 and 35. So, you know what, I would follow mine over and I would say, okay, I go like this. Well, I kind of started to go downhill a little bit. I'm going to go with about 33, okay? I have no idea what it's supposed to be exactly, but I'm going to say according to my graph, I think it's about 33. Mine went downhill, so maybe I should just get it better. So I'm going to follow straight across and say, you know what, I think that's about 33. And then I'll come down here and answer as a sentence, okay? The lava moved. About, we were estimating, we didn't use the equation to get it exact. The lava moved about 33 miles, maybe you said 32, maybe you said 34, whatever your graph shows, you go with. The lava moved about 33 miles in 5.5 hours. Give a complete amount of information. Just it moved 33 miles doesn't say, well, it doesn't take quite enough. How long did it take to do that? So, did we use the equation at all to do our estimating? No. Okay, anybody have any questions? Hearing none.